All right, and we should be going live right about now. Let me get the announcement up and ready. For people in our Discord chat, once you hear me say, hello, how are you doing? Please let me know so I know that we are actually live. Thank you.
How is everyone doing this morning? I hope you guys are doing well.
All right, it looks like we are good to go.
Fantastic.
All right,
Okay.
so for everyone in chat, give us just about a minute or two to sort of let people filter in as we get the live stream started, and also for me to make an announcement in Discord. And then I will do the proper introductions and let you all know what this event is about and introduce Keith, who will be running this workshop for us. While we get started, if everyone in chat, let me know sort of what you've been building recently in Python.
We are going to have a good time today, I think. Take it easy and build some fun stuff. That's right. We are both in a Discord chat and a YouTube chat, by the way. If you are over on YouTube and have not ventured over to the Discord, it is a very nice place.
We promise we don't bite.
Mo doesn't bite either. He just smiles and is happy and helps keep this camera in focus.
All right, well, I think it has been about enough time. So let me do the proper introductions. So welcome to the Fancy Hat Workshop, hosted by our very own Keith, known as Keith the Double E, or Keith the EE over in Discord. This event has sort of been about a year or two in the making, based on one of our previous Python release streams that we helped host. But I will also let Keith explain the backstory. For those that don't know my magical voice, hi, I am Kat, aka Janine. I am the events lead for the Discord server. You will just be hearing my voice today, no camera from me. But otherwise, Keith, take it away.
Okay. Hey all, I am Keith. As Kat said, I'm Keith the EE, or alternatively, my favorite aspect of that handle is Keithy. It works. We are going to be building a fancy hat. And this hat is going to give us some scrolling text, and this is basically going to be what the final product looks like. It is a nice little top hat. We thought of this idea of a workshop because a few years ago, October-ish of 2021, I do believe, the Discord helped out with the Python 3.10 release. And as a result, we get an opportunity to talk with some of the core developers, and they had some nice hats. One of them, Pablo, the release manager, had a really fancy hat with scrolling text and everything. And being the server of nerds that we are, we all went, oh, we could make that. So we looked into it. CircuitPython lets us preserve our experience with Python. And then the only other barrier to entry is electronics, which can seem to be a lot, but with a lot of Adafruit products and with CircuitPython and with learn guides and tutorials that are out there online, the barrier to entry to building this kind of hat is really small. And we're going to go from ground up to building a hat that has scrolling text and a couple of other fun features, hopefully. That said, there is a good question of what is CircuitPython. CircuitPython is a version of Python that is aimed at microcontrollers. Microcontrollers are like really tiny computers, but there's a bit of a distinction between a microcontroller and a Raspberry Pi. To a specific degree, that line is getting increasingly blurred as technology becomes more powerful and we are able to do more with less. That said, CircuitPython is not strictly Python. It is an implementation of a subset of Python. So if you are expecting whether or not it's 3.11 or 3.10, it's technically none of those. It's its own thing, but it preserves enough of the Python syntax and core language that you can be writing code like you're used to writing in a Python environment, and then end up with code that can run on a microcontroller in a script-like fashion. In fact, you can do some kind of really fun things with some microcontrollers, and I'm going to quickly highlight some of the microcontrollers I've got, and then we can look into some of what they can do. So this hat is running on a Adafruit Playground or CircuitPython Playground Bluefruit. And it is a small Bluetooth microcontroller or Bluetooth-enabled microcontroller that has a whole bunch of sensors built in on it. In fact, it's got buttons, LEDs, accelerometers, microphones, slide switches. It has the option for battery and just a whole bunch of little things. The Circuit Playground Bluefruit and the Circuit Playground Express are two great little microcontroller boards. If you've never played with a microcontroller or any sensors and you don't really necessarily want to buy like a full kit, the Bluefruit and the Playground Express are fantastic boards that let you explore that.
And for those who are wondering if they can get links to these things for future experimentation, we will be providing a list of resources after this workshop that will also have links to some of these things and also alternatives if you need them. So don't worry if you need to quickly scramble, write down names. We will have a handy dandy list of links and resources after the stream.
Yeah, we're going to have a whole bunch of stuff, and you can kind of take it in a lot of different directions. It's hopefully going to be really nice. Oh, hey, Tammy. Hope your Saturday is going well. Hope everyone's Saturday in chat is going as well as well. Other boards that you might be somewhat familiar with, Raspberry Pi. It is technically an embedded Linux device, but it is a wonderful gateway into the world of microcontrollers and sensors. So then we also have the Bluefruit there. One that you might also be familiar with is an Arduino Uno. This kind of helped revolutionize the hobbyist microcontroller world. When I started college, it was absolutely brand new. I think it cost $60 at the time, and that was a huge, it was exceptionally cheap compared to what had been previously used, which was a Motorola something or other. And that Motorola product was either $100 or $200. I can't quite remember. It's been a good long time. And going from those products to the Arduino at $60, and then very shortly thereafter it was $40, we have come a long way. And there are now the Raspberry Pi Pico, which the Pico itself is $4. So the world of hobbyist electronics has become exceptionally more accessible. It is a microcontroller. They also have a wireless version so that you can do IoT-related products. There are ESP families of sensors that have a little Wi-Fi chip on them. Mo's trying to get the focus here. And these also let you do wireless IoT products. I have a large number of ESP products around my house doing just smart home tasks. And so that's just a brief overview of what boards are out there. There's a ton of products or projects you can do with these different boards. I have 4 or 5 air quality sensors throughout my apartment. I have a couple of e-ink displays that help display the status of them and slowly update over time. There we go. This is an ESP32 Pico. It is, I think, roughly the size, not a Pico, ESP32 S2 Cutie Pie. I think it is roughly the size of a quarter. It is a very nice small form factor. And paired with this one is an accelerometer, which lets us go ahead and take sensor readings from it and do some really kind of fun things. So you can pair it with other programs like Python in a Jupyter notebook, and then just build a little real-time plot of what the sensor values are reading. All of this is a whole lot to say that sensors and microcontrollers are exceptionally accessible now, and you can do a lot of really, really neat things. So we're going to be building this fancy hat with text scrolling. It's going to have some sensor responsivity in it if we get to it today. If not, the code to extend the hat to like change when you tilt your head is going to be available. We will have resources for it, and the ability to take this hat a little bit further than where we leave it is going to be very, very accessible for everyone.
So Keith, I have a question for you. I have a bit of experience with microcontrollers, but it's mostly from like coding in C. How does CircuitPython compare to just coding in C? And why do you like using Python for this?
The best, oh boy, CircuitPython compares to C in a lot of different ways. C is going to be faster. It is going to use less memory, but you are going to fight the compiler and you are going to fight the error statements. CircuitPython makes it way easier to just write code and have it run on the microcontroller you're playing with. So that rapid development loop is absolutely exceptional with CircuitPython. And because I'm very familiar with Python and I'm not as capable with C, it is much easier for me to write Python code. And as such, especially around home projects where I don't want to go through a month-long process of a development cycle, it's just much faster to get a project up and running from the word go. So I just swapped what microcontroller was connected to the computer. The code for that microcontroller is up here on the screen, and we can very, very quickly go through and just change it from Hello Python Discord to changing code is as easy as hitting save. And then I just hit Control Save, and then the microcontroller notices that there is new code on there. And that change is immediately reflected in the hat. Right now I have a little brightness and dimming function going, but it gets a bit dark, so we'll change how dim it goes so it stays a bit more bounded. But we already have changed the code and immediately done 2 changes to the code that was running on this microcontroller with very, very little effort. And I've programmed in Arduino C, and this rapid development cycle is not something I ever experienced on the Arduino.
So a follow-up question from Vivax. Does CircuitPython compile to native code, or does it embed a Python runtime?
Oh boy. Okay, you're going to stretch my knowledge of CircuitPython, and that was immediately going to be what happened in this presentation, which is part of why I'm excited to give it, because there's just a lot I don't know, and your questions are going to help me identify. To my knowledge, when you put CircuitPython on a microcontroller, which is a process we're going to go through today, it is a program that looks for a file called code.py. Then when it sees that code.py file, the program that runs on the microcontroller iterates through the code.py file. So there is a Python program running on the bare metal, and then it steps through the program you write. And that's how the code is updated. So it doesn't compile, it iterates. So if we end up with an error partway through this, let's do, what is something that's kind of impossible, but wouldn't be a syntax error? Text. Text is not divisible because divisible because text is a string. That should give us a runtime error. And I can't remember what kind of error it's going to be, but it should give us an error, and it shouldn't be an error that occurs let's see. Yeah, let's do hello. Let's see what happens right there. Okay, so it's not getting to that point. Am I in the correct file? Looks like it. So is my scroll text while true? I do not know why we're not hitting this point. Oh, okay. We're not hitting that point. Cool. So that is a great example of it will go through your code until it can't make it there. It will go through your code until it runs into a bug, and then it will give you a traceback. So it is not an error that is identified at compile time. It's identified during runtime. And another point that is really nice to know is you don't need Python on your computer to get this error. This error and the traceback are all generated on the microcontroller itself. And all generated on the microcontroller itself. One day I will finish the sentence. So you don't need to worry about making sure you have a specific version of Python installed on your computer. It is all installed exclusively and running exclusively off of the microcontroller.
So another question from Vivax. The terminal you have on the right, that is a serial monitor?
Yes, I am using Screen because it was already installed on my computer and I didn't have to add anything. But it's just reading from serial, and similarly, this program to grab the output of the accelerometer is just reading the serial and assigning packets that it gets from a serial read line into a data value, and then it's passing that data value off to the plot. So all of this in Screen could be replaced with the PySerial package.
All right. Well, thank you for the slight tangent to answer some questions.
Yeah, we were always going to hit those. I think that is a pretty good explanation. One other things I do want to touch on is that CircuitPython is itself a fork of the MicroPython project. They are two separate projects that kind of run in parallel, whose goal is to put Python on a microcontroller. I believe a good way to summarize the distinction between CircuitPython and MicroPython is MicroPython will try and get the most out of every microcontroller you put it on. So it will have reach into sort of all of the weird, nuanced aspects of the chip you're using, assuming it's compiled to do that. CircuitPython will try and preserve the user experience across multiple chip families. So your experience in CircuitPython is going to be consistent, but you might give up a little bit of optimization, where MicroPython is going to get a little bit more out of each chip, but your experience might be a bit different. So with CircuitPython, it's really easy to just copy and paste from one microcontroller to another. With MicroPython, it's pretty easy, but it's slightly more difficult than is the case with CircuitPython. MicroPython's a really awesome project. Like CircuitPython, the people involved are fantastic, and the two projects commonly get together to look at what the other project has been adding into its code base and what optimizations and improvements they can share. Both projects are fantastic. I am more familiar with CircuitPython, so we're doing that with our hat today. But if you want to pursue and explore the MicroPython world, they are fantastic as well, and I highly encourage you to do so. With that, I think we should probably start taking a look at the hat and start talking about the parts of it. Unless, or during that, if you have further questions, please feel free. Okay, so we're going to build a text scrolling hat. And again, if you've got questions throughout this process, please do ask them. I will endeavor to answer them. Katney is also in the chat and fantastically experienced with CircuitPython, and I believe she will be happy to answer questions as well to the best of her abilities. Okay, so when building a text scrolling hat, you're going to want a hat. Hats are helpful for that. We are also going to use a microcontroller. I have misplaced the one I was going to use. Here we are. We're going to get another. Oh yeah, Tammy makes things as well. She is fantastic and also exceptionally knowledgeable. There's a lot of folks in chat who are really smart and way more knowledgeable than myself. And I'm very excited to have them joining us today. And yeah, it's going to be a fun build along. So one of the other things we're going to use for this text scrolling hat is a flexible LED screen. So this is, or LED matrix. That is what this is. We are going to open these up. A lot of this is going to be the first test of these products because worst case scenario, I'll just pilfer parts from that one. I like showing off what the final product will be. That way, if you are interested in it, you can pay attention, and you can also notice things you hadn't necessarily thought of beforehand. Let's see. And then this is what our RGB matrix looks like. It is an 8x8 LED matrix on a flexible material so that we can have it conform to the curve of the hat. Our connectors on the backside are a data in and data out connector, and then power and ground. We will address those as they come up, but just as a heads up, and because this matrix is only an 8x8, I went with getting two of these matrices because it makes it a lot easier to read text when you have more than 8 pixels of a character. Okay, other useful things we're going to have. Scissors. I have some Velcro material that we will apply to the back of the matrices to help adhere them to the hat. We're also going to be using an X-Acto knife to make holes in the hat, and pencil to help identify the spot to make the cut for these incisions. It's going to be pretty low key. Yeah, that's what this process is going to be about. Okay. Before we wire everything up to the hat,
I'm going to briefly interrupt for a question.
Go for it.
What is the small round component between the two LED matrices, just for the people that joined a little bit later?
Oh, hey, fantastic. That is going to be the brains of this hat. This is going to be the microcontroller. It is a Circuit Playground Bluefruit. And we've chosen this one specifically because you can connect to it with alligator clips and you don't need to solder.
All right, so fantastic. So what is the next step now that we have sort of all the components together?
Now that we have all the components together, we are going to do a sort of dry run test. So first, we need to get CircuitPython on this guy. A version of CircuitPython is already on this, but it's a bit out of date, so we're going to go through the process of updating it. Then we are going to connect the matrices together, and then we're going to connect them to the microcontroller. And then we are going to slowly put code on the microcontroller that will end up looking like this. But we'll do some small tests first, just as a proof of concept to make sure that everything is functioning on this. And then once we have enough up and running, we're going to go through the process of applying it to the hat. But the very first thing we want to do is make sure that everything works before we get it committed to where it is on the hat. And yeah, so we are going to put CircuitPython on this guy. Okay, as such, I'm going to swap the hat around. Mo is going to stand over there. And we are going to get this plugged in. It's going to be just kind of a nice and slow, relaxed build. Okay. This is a trick I wish I learned in college. Take components down, they slide around a lot less. It is annoyingly simple and exceptionally effective when it comes to building stuff. Okay. Oh, I have to plug the hat back in. I do kind of want that running in the background. Okay, let's get a new one of these up and running. Okay. There we are. We are also going to go to CircuitPython. And then we're going to go into downloads. So CircuitPython.org is a great way to explore what types of boards are out there that CircuitPython can run on. The downloads page will show you which boards have the most downloads. It is sorted according to most recent downloads. And we want, in this case, the Circuit Playground Bluefruit. We are going to run CircuitPython 8.0.3. 8.0 has just recently been released, so we want to upgrade it. Upgrade the version that's running on this. I think, let's see. Yeah, this is running 7.2.5, so we are going to give it quite a bit of an upgrade. So we're going to go ahead and download the .uf2. And then it'll download, and then trying to figure out, there we are. I already have this from binary, Circuit Playground Bluefruit, and stable. Okay, so this is the version we are going to put on CircuitPython. And to do so, we are going to reset it, and then we're going to hit reset pretty quickly on it. Then it's going to go blue, and it's going to show that we want to do the Circuit Playground boot. That's going to let us drag and drop this over. However, I'm going to go through and show the Learn Guide and the overview for the Circuit Playground Bluefruit. So this tells you a lot more about what you can do with the Bluefruit, what it has. It has a Cortex NRF 52840 Cortex M4 processor with BLE support. It's got 10 neopixels around the ring, those little guys. And you can kind of see that it is currently bright green. However, because of light balance in the camera, it looks fairly white instead of green. It's got a bunch of buttons, slide switches, and that's why I recommend this as a good board if you've never bought sensors before and you're not entirely sure how far you want to dip your toe into the microcontroller world. This board has a lot built in. That way you can just kind of get this and start getting a feel for what the world of CircuitPython is like, what microcontrollers are like, what you can do with sensors and all that. So we are going to do and go towards CircuitPython. We've already got this downloaded. We already have this in the bootloader mode. But just to show you this process, it goes through and you need a data cable for USB. We've got that taken care of. We're clicking it quickly in its startup, and that's how we got into this mode. And we are right where we should be. We see that. Now, this is one of the best parts. This is the version we want. We are now just dragging it. And you should see this has changed colors. This has changed colors. Figuring out how to point in this is an experience. And that's because it is going through and doing the upgrade and installing the new version of CircuitPython. It has now come back, and we should see CircuitPython show up. And that is the process. And if we go back to this, we can go ahead and enter the REPL, and we can see that we are now in CircuitPython 8.0.3. And if you've never played with microcontrollers, that might have seemed like just kind of like, what's all that about? I have, and this process to upgrade the version of CircuitPython on here is exceptionally nice. I dragged and dropped things on, and I've only been using this terminal to show that the dragging and dropping worked. I didn't have to type anything in. It's really, really nice. I know we're a Python Discord, and you're probably not that terminal adverse. However, this is a really, really nice feature. But we have done it. We've put CircuitPython on this board. We have upgraded the version of CircuitPython, and now we are about ready to start exploring putting together the LED matrices with the Bluefruit. Do you guys have any questions as I'm going to transition into the next phase?
There was a question earlier from Robin asking, does the CircuitPython work in an Arduino Uno? Myself and Katney were kind of able to answer that we don't think it quite has enough memory, but there are on circuitpython.org/downloads. It does show all 373 boards that are confirmed to run CircuitPython. There are possibly additional boards that can run this, but these 373 are confirmed to run it. And it's just a matter of sort of checking the memory specs is sort of the big one there.
Yeah, that covers that quite thoroughly. Going through this process of figuring some stuff out. Arduino cannot run, or Arduino Uno cannot run CircuitPython. The space required for that the space required for you can literally hear my brain just grinding to a halt during this. The space required for the CircuitPython code base that lets you write your code.py file is just too large for the Arduino Uno. We do have a pinned post in the Microcontrollers channel that does talk about ways to get Python-esque code on the Arduino Uno, and that does involve, again, my brain has just absolutely stopped. That does involve sort of like a serial back and forth between the computer and the Arduino Uno. But the pinned post in the microcontroller channel does have a whole lot of information on that.
Oh yes, now is the perfect time. On Python Discord, we do have a microcontrollers channel. It is certainly not the most active channel, but we love to have that channel there because it shows that you can interact with microcontrollers with Python. So we have some great resources pinned in that channel, so feel free to stop by if you need any more help following the stream. After this stream. That's the wording I needed.
Okay. Sorry, I'm getting some cheating set up and ready to go. So we want to run this LED matrix on our Bluefruit. To drive the LEDs, you're going to need some helper libraries. So let's go over to circuitpython.org. Let's go ahead and download the libraries. Now, you don't put every one of these libraries onto your board at the same time. You sort of build a project, in this case, our LED hat that we have scrolling over here. You build a project And for that project, you will probably need some peripheral stuff here and there. And that's all you add to your CircuitPython library. Jumping around in the background. So we're going to go through the library bundle and download that. We are going to download the 8.x because we are running CircuitPython 8.0.3. And this will give us a list of libraries for the whatever we are building. Okay, I apologize. This is just going to be tiny text on a screen. There's not a ton I can do with that. And okay, interesting. Okay, so when you download the library bundle, it'll come in a zip file, and then when you unpack it, it's going to look like this. I have bundles for 6, 7, and now 8. And within this, you'll have the libraries themselves. When you build a project, you might need the library for the BME 20 or BME 2080 or 280. This specific sensor is a pressure, temperature, and humidity sensor. And this is the code that lets a microcontroller access. It's the code that lets a microcontroller use the sensor with ease. You can write all the drivers yourself, or you can just use the library in the library bundle. So inside this, you'll have a .mpy file. And for the BME 280, you would just add this whole folder into your onto your microcontroller. So in the case of the BME 280, you would go under the library folder and you would drag and drop it into there. And then in your library microcontroller code.py file, or if you want to use the REPL, you can just do import Adafruit BME 280. And then you have access to how to read the sensor, how to do calibration stuff for the sensor, and all that. But that's a very, very cursory overview of using the library bundle. It is pretty much drag and drop. Further on down in the bundle, we're going to zoom out. There'll be just flat MPY files. So the difference between the flat MPY files and the folders are basically, for one reason or another, these programs need more files in order to run efficiently. So the BME 280 has a basic version and an advanced version. So if you just need basic temperature, humidity, and pressure sensors, you can just import the basics. However, it is a .mpy file, not a .py file. So it is a, how would you put it? It's compressed, and it's it has a version of compression on it so that you can't simply run it. Let's get a new window going over here. And then I'll grab give me just a few moments, and I'm going to run over to the CircuitPython library and Yeah, that'll do. I'll throw this up over here. No. There we go. Okay, so jumping over to the library bundle, and all I'm going to do is just quickly show you kind of a look inside the .mpy files. We are going to do cd there. Oh, wait, no, I need to go here. Okay. So the .mpy file has a version of compression on it. It basically strips a lot of references out, but a lot of the strings are preserved. And you can see that using strings and then just running over that. And you can just kind of see it's got mode selectable, a lot of the variable names that you will need. To call are all preserved there because the program still needs to know what that string is. But a lot of the internal references and stuff that can be filtered out are reduced down to sort of a binary representation. And if we want to go ahead and see what is in the basics, we can go over to Adafruit's GitHub. Adafruit, CircuitPython, GitHub, BME 280. So the .mpy file is going to show you is going to be a compressed version. The uncompressed version is this, and this is far too small for anyone to see. There we are, one larger. Okay. This is a very, very long explanation of what the libraries are. This is very exciting to me. I appreciate everyone willing to bear with me, but it's also going to help me just kind of shunt files from the library bundle into the microcontroller. And you guys can always ask questions and interject. I'm terrible at reading chat, but Kat is exceptionally helpful at jumping in.
I am but a voice for the masses. And Kattni brings up sort of a good explanation to sort of add on to Keats that a .mpy file is a PY file, but compiled down to the bytecode. The benefit of this is that it makes it use less memory, which when you're working on memory-constrained microcontrollers is a good thing. So thank you, Kattni.
That is a much more concise and pointed explanation than what I offered. Thank you so much for that. But yeah, this has a whole lot of white space and like comments, which are great for us as humans, but a microcontroller does not have a whole lot of space. So a lot of these strings are just reduced and compiled down to a bytecode, and this is just kind of what's left over string-wise at the very end of it, which is significantly reduced. Now, obviously, we're abstracting away all of the bytes that are not represented by strings. So it's not like this is all there is in the file. There is wildly more than this, but it does compress a lot of these strings in the raw file down into this. If you wanted, you can absolutely drop this .py file, basics.py, onto the microcontroller, and it will happily take it and run with it. You're just going to run out of space much more rapidly than if you weren't taking from the library bundle MPY file. That's a very, very long-winded explanation, but all of that is because in order to stick code to drive this onto the Bluefruit, we're going to take advantage of the library bundle, and we're going to put a few things on there. Let's see, we're already in the CircuitPython, we're in the library. we're going to get rid of a few of these just for space. I'm going to drop that one. Don't need that one. I'm going to keep that. I'm going to keep that. And I'm going to keep that. And over here, I'm going to get a couple of other things up and running. Do I have a good explanation as to why I want these libraries? LEDs. LEDs are awesome. I love them. The reason I got into CircuitPython was because I had a strip of WS11. Is it WS1128s? Which are like the version before NeoPixel. But I had individually addressable RGB LEDs. And they run a alarm clock light next to my bedside. In the mornings, it turns blue, and that really, really helps me wake up. And similarly, at nights, it'll turn red. I love it, and it was a lot of fun, and I fought C so much in order to get it to work on an Arduino. And then I found out about CircuitPython, and it is just much easier to deal with stuff on CircuitPython. So if you're interested in LEDs, the NeoPixel Uber Guide is a fantastic place to go. It just has so much information and covers just about everything you need. Jumping over to CircuitPython, it's got some wiring heads up. So if you have a Feather, it has a wiring example for that. If you'd instead wire it to a Raspberry Pi, it has examples for this. For putting code onto your Raspberry or onto your CircuitPython board, you'll want some of these libraries. NeoPixel.py or MPY is a really important one. Bus Device is a really good one for other ones. In this case, we are going to go ahead to the library and grab this folder. I just need to hit that. Drop that over there. Then I need frame buffer. And I know these files because I have a cheat over here that I am just copying off of. Then I'm also going to need pixel frame buffer. And then we already have neopixel.py on here. And then we're just going to jump over to screen and make sure that it is not upset with anything we have dropped on there. But it seems to be quite happy with whatever's code is running on it. Which is an audio player. We're going to go ahead and get rid of all of this code, and we're going to start again, built off of my cheat file. We're going to start going through and talking about what we need to have code-wise in order to drive these LEDs. And I'm just going to kind of burn through some of these points. If you guys have questions or would like me to dive into it in more depth, feel free to ask and let me know. We are going to work towards getting a image LED something on the LED matrices we have. So we're going to be doing a combination of working with the code and then jumping over here and kind of connecting some things together. And that's what this process is going to be. Again, it's going to be fairly relaxed. We're going to take our time and have some fun with it. I am going to go ahead and find a Learn guide for this. Okay, so this is one of the libraries I am using, Pixel Frame Buffer. And to help me figure out what to do with it, Adafruit has a whole bunch of Learn guides. We're going to just kind of step through and figure stuff out. And I have my cheat notebook with me so that we can do a whole lot here. It is upset about something. I don't quite know what. That's okay. Okay. I should pull up chat while I do this. If I can remember where it is. There we are. Okay. We are not on a Raspberry Pi, so these processes are for two reasons. In my editor, I don't have a sort of fake file pretending to be this. So my editor gets very, very confused with everything and very, very upset with the fact that it cannot find Adafruit Pixel Frame Buffer. As such, you can install, and Kattni, you're going to have to help me on this one. I can't remember what these are called, but they're basically hollow files that have the naming structure of the entire library available. So you can say, I'm going to import this, and then your editor doesn't scream and yell at you. My workflow never really paid attention to it, so I haven't added that in. So you can install these. You can install these libraries, and your editor will be less upset. Stubs, thank you.
Yes, those are called
my goodness.
stubs. They're also common for other elements of Python. This isn't really a microcontroller specific thing, but typically if you want like specific type hinting for a library, you can sort of install separate stubs to help with that. And it makes the coding process a lot easier if you use a sort of more advanced editor or an IDE.
Okay, fantastic. One of my favorite parts about this is my approach to programming in general is very, very haphazard. I will never try to be the best at this kind of thing. I am always here to solve my problems within my given constraints as easily as possible. That means, because I am not attempting to be the best, I have a wealth of things to learn from. And that is a fantastic place to be, in my opinion, because that means I always have something new to work on and new to do. Okay. So we kind of have, I suppose I'll jump over here real quickly. We kind of have a basic idea. We need a board, NeoPixel, this frame buffer, and this is just walking through this guide. But we have a very, very basic idea of, okay, we have pixels are going to be addressed on some sort of data pin. We have to define the width and the height of the pixels. Then we're going to create a NeoPixel structure and all that. So one of the things we need to think about is, where are we going to connect things? Remember how I said there was audio code on this? I forgot to hit save and remove that code. Okay, cool. So if you heard a noise there, that's because there was a noise. I had completely forgotten it was on there. Yeah, so we're going to start wiring stuff up and kind of being mindful of how to do this. So, nope, that's not the right button. Let's go over to our workstation camera. When looking at this, this product has 3 wires effectively. It is going to have a ground, and that ground is going to be shared across all of these. The white is the data line, and I believe that is identified on this little flag. Yeah, this little flag here gives us a breakdown of what's on these. So when you chain LEDs together, you're going to want to add power at different points. You're not going to want to power it at the very beginning and hope it gets all the way to the very end. You're going to want to give it a little boost every now and then. So these little matrices have a data that can go all the way through to the end, but the power doesn't chain because you're going to want to put them together, or you're going to want to give it a boost. So thinking about the way we want to look at these neopixels, fitting it into the hat, it'll probably make sense to have the neopixels set down, and then we can look at our hat, go along the brim of the hat, and then use this ribbon to hide the cuts that we're going to make. And then we can insert the cables along that little bottom line and then pull the cabling through over here. So that means these 2 matrices are going to sit where the bottom wires both aim out in the same direction. And that means let's chain this to this. Then we will get positive together, and then we will do data like that. So then we want to figure out which one is going to be the start cable. I think this guy is going to be our start. Worst case scenario, I cut the wrong thing and we are filled with regret. Oh, here we go. Nope, data in. The very, very bottom beneath all this hot snot, it's got a little bit of info on it. I don't know that it's going to want to focus. That's okay. There's data in on this side, and this side will read data out as a result.
Yeah, camera focusing is not always our friend. Katney also mentions that it's important to identify which one is data in versus data out because data kind of flows in a particular direction. So if you kind of mix it up, you will not get the results you want.
Yeah. Okay, so we have identified that this one is data in. And if we had messed this up, which I did over here, because of the nature of this build, it is very just kind of relaxed. It's a hat that has scrolling text. It's going to be okay if we mess it up and we have to make another cut and then reorganize these matrices. It'll be just fine if we do that. But since we have the opportunity to make the correct choice, let's go for it. Okay, I've got a lot prepared, but I did forget to set aside my wire cutters. Well, those will be wire cutters. Okay. So next thing I have to do is take this cable and strip it down some so that I can connect it to an alligator clip and connect that to this, which is also helpful with wire cutters. But I've done this before.
So for those not super familiar with some of sort of the electronic terms, stripping it is all the wires are sort of covered in like protective like plastic sheath. We want to expose just a little bit of the wire to actually get things to flow, connect metal to metal. You can do this with the sort of a knife or wire strippers. You just need something to sort of score that little plastic piece a little bit and then pull it off so you can have some of that wire exposed to do the connection.
It's not the way I would recommend it. I have pencils set aside. I have multiple types of fasteners. And naturally, I had to forget something. So as far as it goes, that's not a terrible thing to forget about.
There are certainly ways that you can strip wires. Some of them I feel like I may be obligated to say don't try at home, but like, yeah, I've stripped it with my teeth before. You can do some janky ways to strip wires in a paint.
Okay, we are going to preserve white to white and reds to red. So red is going to be your input power. Each on this one. 5. Hopefully this bites. If it doesn't, we'll figure it out. But yeah, wire stripping is one of those things where it's always like, yeah, I shouldn't have done it, but I needed to. I feel like that's an aspect of a rite of passage.
Yeah, everyone will sort of go through the microcontroller phase and realize that like the tool they need is like in a different room, or they forgot it, or it's just not quite working. And you learn to be resourceful. It's a good skill to gain.
It is also a, I'll call it a forcing factor for learning that sleep is very, very important. And sometimes you just need to call it and go to bed. That's okay. Likewise, I just need to get actual wire strippers. I can't keep doing that. That one needs to go. There they are. Okay. It is tinned on the tip. There we go. So it's tinned on the tip means there's a little bit of solder on the very tip to keep the individual wires from splaying out. That way it's sort of easy to work with. But because of that, it has a slightly larger diameter, and you can't easily strip the tip of the wire without having to push around the tinning. Okay, so far we have data in connected. We have power in, and the next thing we need to do is ground. And ground will be shared. And it's not the best practice to only do ground on one side. As you work with electronics that do faster and faster communications, there's an entire family of design principles that are just basically extra ways to avoid degradation in signal, and having more access to ground than what I'm doing right now is a way to increase the quality of your signal. But right now, we don't really need to worry too much. Oh, hey, Katney. Yeah, that was tinned. This is a part of the build where I just do not have access to chat. Okay, so I'm going to connect up ground because ground is always a nice thing to have connected. And then we are going to decide which pin we want to connect our data on, and then also high voltage. But we're not going to connect those guys up just yet because it's not always the best idea to connect power to something when you don't know what code is going to run on it. These guys are pretty resilient. They'll be fine. But as a good practice, we are going to identify what pin we want this on. Okay, I am going to pull up my cheat code and then also pull up the code you guys see. So looking at this, it's running on D6. So that is data pin 6. And common nomenclature in a lot of these things are, if it's a D, that means it's a digital GPIO pin, so you can toggle it for digital. If it's A, it can do analog values, so it's between, it can do a range in between 3.3 volts and 0 volts, and you can move it to like 0.5. So we are going to borrow this code because I think it's identical to my cheat code. We have those guys on here. I'm going to drop this code in here. We've already imported a bunch of this, so we're going to go ahead and get rid of that. So we're looking at data 6. However, we don't have a width of 8 and a height of 4. We have a width of 16 and a height of 8. Let's go ahead and change those numbers to fit the setup we've got. That's an all right starting brightness. I like to keep the NeoPixels really dim. It improves their life, and because we're just powering it off of this guy, it is really, really helpful to keep the microcontroller from having to struggle. But so far, we have imported the board, which is just a file that has a whole bunch of information about the circuit playground Bluefruit. We've defined our matrix width and height, and it's kind of a loose definition because we have two matrices. But we're defining a pixels class, which is going to be from the NeoPixel class. It's going to have a pin where the data is on. It's going to have a number of pixels in it. It's going to have a set brightness. And we aren't going to let it write immediately. We are going to hold that off. So we're going to save that. It's not doing anything yet, so we don't need to worry about connecting stuff. But we do know what this pin is going to be. So we can go ahead and make that connection right now. I suppose workstation is a better choice here. D6, where are you? I'm going to cheat and look at my other one. It doesn't look right. No, it does. I'm just a fool. That's okay. It's something I'm used to. We're going to go ahead and connect that up. And you can see this LED is turning on when I... that is really going to be hard to see, actually. There we are. That's better. When I connected power to it, it kind of was like, I think I see a signal. I'm sure I'll turn this guy on. Now we can go back to the setup. So those are dot stars. So that helped us do some of our initial stuff. Next up, we are going to look at the pixel frame buffer class. So this is going to kind of define how these are connected. And I'm going to add a couple of extra things right off the bat because I have cheat code and we are already a bit over time. So in order to talk with the pixels, it's going to need the pixels class. It expects a height of 8 and a width of 16. It has an alternating pattern. And that just means 1, 2, 3, 9, 10, 11. Oh boy. 17, 18, 19. So as the LEDs are woven into the matrix, it just kind of alternates rather than going 0 to 8, 9 to 10, or 9 to 16, and then going back over. And then that's going to be stuff that we play with. This helps figure out where the text is and what it looks like. And really quickly, let's go ahead and bring in some animations. We're also going to want to have this code over here. We are going to drop in some LED animations. So these add rainbow effects. And we're going to do that mostly as a very quick proof of concept. So we are going to define, let's do rainbow sparkle. And then I'm going to get this over here, there. Okay, now hopefully stuff works. Let's take a quick look. I can't see. I am not seeing LED behavior. So now we need to go through and double check these.
And this is a classic part of troubleshooting whenever you start dealing with sort of physical components is check your wires, all sorts of things. It's very similar to if you're coding and you get a syntax error, you're like, okay, let me just double check everything is right. You kind of run through things again. Unfortunately, real life connections don't have handy dandy linters and checkers to help you find these things. So you have to do it manually.
And it should be rainbows now. And the issue was exceptionally dumb. And I'm very excited that I made that mistake. Okay, so what happened? White or black are very frequently ground. So I connected the data line adhering to the standard set by these panels. I connected the data line to ground, and then I connected the ground line to data. That's going to happen. That's going to happen a lot. And I'm actually thrilled that I made that mistake because that is annoyingly common. But we now have matrices that are connected. They work, and we can double check that they go together. So I think you can kind of see the color pattern moving across, whereas if I had them in this orientation, there is a break across the middle. It's going to be a lot easier to see when I write scrolling text. Sorry, I keep shorting everything out. But, okay. So here we have LED panels that are working. We have CircuitPython running on microcontroller. we have kind of some base level code. I'm going to go ahead and drop in the blocks of code that define the scrolling text, and we can walk backwards and explain that as is. But we're going to take a mark of where the panels are and then put a few cuts into the hat and get the panels mounted onto the hat, and we're pretty far along. How are you all doing, chat? So frame buffer, we can find that.
Chat is having a great time. We are sort of discussing the distinction between a Raspberry Pi full computer and something like the Pico, and sort of the differences there, especially in affordability and availability. And that the Pico is still like very powerful, even for a microcontroller. And just revisiting the concept of stubs.
Awesome. And we'll have to go back and review it. So I'm going to go ahead and drop in some code. We're going to create just our nice little string, hello Python Discord. Get a little bit of padding so that when it starts, it doesn't start with the H ready to scroll off of the screen. Then we're going to run through a function called scroll text, and we're just going to quickly build that. We're going to keep that over there. Okay. Let's do this a bit iteratively. Let me go ahead and go over here. Then we are going to okay. I think this should have everything that we need in order to write some text. So on the microcontroller, we have a font file. I feel like I'm going to miss something. So let's control save and see what blows up, and then we'll just work from there. Let's open up screen so that we can see stuff as it breaks. And come on. There it goes. Okay, so really quickly, running back through, we have the data pin that everything is addressed on. We have a class that defines a neopixel strip and the size. Then we have a pixel frame buffer that has orientation and all of that fun stuff. So it defines how the pixels are just kind of squashed together to form a matrix. And now we are ready to, I think, scroll through and display some text. Let's find out what happens. I feel like something's going to break. Well, that doesn't look like anything is happening. Let's scroll text. So why is nothing happening? What have I forgotten to do? Okay, we have to do the fun thing of checking connections. And because we already have some code. Okay, so we know that connection is working. Scroll text. I'm going to do extra cheating and just copy and paste this entire block. Well, great. That's awesome. Why are you unhappy here? Okay, cool. So the difference between those two, we're just going to drop this below. Actually, no. Let's go ahead and drop this side by side. I have a whole bunch of information up top here. And, oh. No. Who knows? So let's do I have the right colors there? I have the right colors, the right text. Welcome to development. Okay. So this is what's running on the microcontroller, and this is what the microcontroller likes running. We sleep for a period of time.
So the time.sleep is an order of magnitude. Is that the issue?
I don't. Oh, you know what? I think you're right.
I definitely have not done this in the past, for sure. Never. Been sitting there for like 3 minutes wondering why it's not updating, realized there was a 0 missing.
No, it should be running through this. So that's not it, but that is going to get us to the answer faster. I think it might be offset. Because why do I think it would be offset? Start I at 5. Oh boy. Okay, we're not going to scroll text. We're going to stop that for a moment. We are just going to display text. Okay, so we have defined text. We need to pick its location, and then its height offset. So let's pick 10, and then that's its color. Going through, and it is done running. Let's go ahead and do that. That way we know that it's stepped through the display. One, 2, 3. Let's go ahead and do 20 then. I'll be honest, I don't have the slightest clue what the issue is right now. But we are going to crack on anyway, because what we really needed was what this part gave us, which is the ability to confirm these two belong in this order and not this way around. And then, once we have this set up in the hat, we will go ahead and come back to this and figure out what the text scrolling issue is. Because sometimes you just need to take a break from looking at it. And I think making this hat a bit fancy is more fun. Okay, so we're going to swap over to the workstation view and start building. Okay. First, I need to get rid of the tag on this. There we are. And then what we want is to have a way to see that these two go this direction. So I am going to do a nice little cheat and use some tape. And we're just going to put some tape on the share side of the matrices. That way we know that it goes from here to here. Then we can go ahead and make a little rip. In theory. Come on. There we go. Okay. So now we know the shared side of these two matrices. We can disconnect everything. Which one is power? Then data. Then ground. And we're going to have to disconnect this bit as well. Disconnect these guys. Disconnect data. And there we are. Okay, so now we've got these. And I want to set them on the hat like so, give or take. And figure out the orientation and the framing in camera. And what we're going to be careful about is we don't want to just completely cut this hat all the way open. We're going to want some more or less measured incisions where we want these matrices. That way the cables only go through at that specific location. So to do that, I'm just going to grab a pencil and put some marks on the hat about where these go. So being mindful that this piece of tape needs to sit in the center so that the two screens can share and the text can scroll that way. We're going to place it on the hat kind of roughly there. And then we want, I wonder, is it? Yeah, you can see the ribbon under there. We're going to want the ribbon to kind of hide the cut we are going to make. And we're going to want to put a little mark about the locations where we're going to make some cuts. And it is probably not overly visible on the camera, but it is visible enough for me to extend the mark off of the ribbon onto around here. And then, is that visible at all? Yeah, a little bit. So those three marks are where I'm going to run the X-Acto knife, and we're just going to create a nice little slit for these cables. So the middle one can be significantly smaller because it doesn't have a connector to worry about, but the other two will have to be a little bit larger. And let's just go ahead and double check that placement. Does that seem sufficiently in the middle of the hat? Yeah, I think so. We can go ahead and give ourselves a little bit of an extra line to work with. One more double check. I'm going to go ahead and move these marks over just a skosh. Lining that. And this is just a part of how the build goes. Make a measurement, double check, make a new decision. Okay, I like the way that aligns. This sits along the vertical line I have drawn on the tip of the hat, which, yeah, you can kind of see it there. And then we have a mark for an incision there, and then over here. And we can make the cut below the ribbon line over here. And then on the inside, we will have the cables, make it all the way through, and then we'll pull them out, and we'll get them fastened onto the inside of the hat a little bit more cleanly than in this hat. This is roughly our proof of concept hat, and this is going to be our build-along hat. So, with that, I'm going to go ahead and just take the X-Acto knife and be willing to have regrets, because you're not going to do anything without trying. And you can always fix stuff later. Let's see, this one is the next. This one gets to be the small one. And double check this. That and that. And our next cut is right over there. How's this? Is this all in frame? Sufficiently so? Not much you can do.
Yes, you are in frame. It's all good to go.
Fantastic. Do you have any projects around the house that you're looking at this going, maybe CircuitPython?
I am thinking of some essentially like water sensors for some of my sort of raised garden beds where they're in a box because they tend to dry out faster, and it will just let me know when it needs to be watered because it tends to dry out faster than the rest of my garden schedule. And coding in C is not as fun as coding in Python, so I think I'm going to switch over to CircuitPython for it.
Nice. What kind of sensor are you using for that?
They are conductive sensors. Over time, they will corrode, but they work pretty well for about 3 to 5 years. But they essentially just sense how much moisture via conductance is in the ground and report it from there.
Okay. Nice.
So I get to sort of record some baseline values of what I think is good water, and then I can sort of monitor when it dips below my ideal level.
Okay. I've been thinking about doing that with some of my indoor potted plants, but I think they just dry out way too fast for that to be worthwhile. I have humidity sensors indoors, and I think what I should do is tie a watering schedule to the humidity sensors with some flexibility so that when it's exceptionally dry, the watering schedule increases in its frequency.
Oh, that's very nice. I might incorporate that for some of my indoor things. I know the humidity varies quite a bit, so that'll be nice.
Yeah. We have plant lights in our living room, and they are currently tied to a timer, but they'll eventually be tied um, not to a timer. Eventually be tied to a sort of sleep tracker. And the hope is that at nighttime, they will slowly turn off the lights in the living room and coax us to go to bed based on when we need to get up in the following morning and based on how well we slept the previous night. Okay, so I've got all the incisions made. So the next thing I need to do is probably find a screwdriver and make sure it is easy to slide the cable in, because plastic around this can make it a pain.
If you are trying this at home in the future, having like a softer hat, it may make this easier. Like for instance, I was contemplating doing this with a sort of baseball cap. So that should be a little bit easier to fit the wires through. So it depends on what hat you end up choosing.
Yeah. My partner was also contemplating, she has a jacket that she puts a lot of patches on, doing a sort of chest patch for LEDs. And rather than doing a permanent change like we are doing with this, the idea would be to make a Velcroable patch that you can put on and off.
Oh, that sounds smart.
Okay, that one needs to be just a little bit bigger. Obviously, everyone, if you do this, be careful of your fingers. There will always be projects that claim a little bit, but it's smart to be careful ahead of them. So here we have the first panel with incisions and cables going through. So we're just going to draw that in. And this is the first panel. And then it goes here. So the second half is going to go over here. And I'm going to run those cables in right now.
And the hat begins to come together.
Yeah. Once again, just double checking with the tape to make sure that I'm in the correct placement and I'm putting the right wires where they belong. That is absolutely going to need to be expanded. That's not enough. Using this to help coax it open. But yeah, I have a whole lot of projects. One of my goals is to take all the air quality sensors I have, connect it with some smart home sensing, and change the behavior of stuff based on what it can identify from the air quality sensors. So the evening light idea is a fantastic idea, but if its perceived scheduled bedtime for you is earlier than when you're able to be home that specific night, it doesn't really do you any good. So I'd like it to have a little bit more awareness of if we're at home. There's a few different ways I plan on exploring that. And there we are. And the final one. is almost certainly going to need a little help. Yeah, that's going to need a bit more. And honestly, because this is the end of the hat, I could remove this connector entirely, but that means I can't repurpose this as easily in the future if I do so. So we remove the connector on the first side just because I don't have a matching component. And this one, I'm going to keep it, even though I could get away with getting rid of it. And it would save me the struggle right now. But you never know what you're going to do with projects. And a lot of these are, especially things like an LED hat, are great projects to make and explore, decide if you enjoy this world. And then, if you enjoy this world, you can pilfer parts from an old project that you don't use and add it to what you're interested in. So now we have forced the LEDs cabling through the hat, and we can just kind of put the cabling back and have the LEDs where they are as they would be. And last time for this hat, I Velcroed it in place, but you might notice a bit of a difference between these two faces. This one is a lot darker than the hat I just put together. That's because I found a mesh that really helps make these lights show up on camera a lot more. And I might use that to hold the LEDs in place instead of adding Velcro to these. Make it easier to filter the parts and also make it easier to use the hat for something else. But now that we have it connected, we have to do another cable test because we could have broken something. We're going to connect the two data lines together. Go ahead and grab this data line. Go back onto that. And go ahead and grab ground. We're going to go ahead and connect that. And then, because we do have a bit of a rat's nest in here, I am going to go ahead and start taping some of these down so that we have less of a risk of some shorts. And painter's tape is great. It doesn't leave much of a residue behind. It's very easy to quickly put together. It's very easy to quickly remove. It's cheap. And again, I wish I learned this trick way back in college. It would have made for a whole lot easier all-nighters in the lab.
And you'll also notice in frame, the actual Bluefruit ATA controller, the wires are taped down, which is helpful for sort of keeping it in one place. So very helpful tips and tricks if you're working on a project for a while and don't want things to fall if they have wires pulling on them. Keith sort of showed me that trick and was mentioning it while we were prepping for this event. And it is definitely a useful trick and tip that I'm going to take forward.
It's one of those things that you're like, I mean, I went to college. I know that like tape is not something that you get a degree in, but goodness, it would have helped. I won't say that it would have stopped my all-nighters. I was not the most diligent of students. So I pulled quite a few, and knowing these tricks probably wouldn't have saved me a bunch. But it's one of those things where once you learn it, you're kind of like, oh, darn, that would have saved me so much time and stress. Okay, so I am reconnecting the microcontroller, and I have the cables connected in. And if I haven't messed things up, I should be able to see sparkles. And it's a bit hard to tell the color on here, but the colors go in the correct direction. Because I have cheat code, I am going to go ahead and copy and paste the scrolling text code that works over and run that because I want to double check that we have text going the correct orientation. So it should start saying, hello, Python Discord. And I'd say that is a success. And we even have it jumping up and down from dim to bright.
What great success.
Yeah. So at this point, this is more or less the hat. But I do have these flopping around. You can use these Velcro strips. They are really, really nice. Once the Velcro strips are on and the panels are fastened in, it is difficult to get them apart though. So in this case, I'm going to use a trick I figured out last night. I went to the store in hopes of finding a nice mesh for relatively cheap. I have misplaced it now. Oh, man. If I can't find the mesh, we're just going to go ahead and Velcro it down. Man. Yeah, nothing's ever where you need it to be when you need it. That's okay. We'll Velcro it down, and then I'll put the mesh on it when I find it, inevitably once half of the hat is Velcroed. Yeah. Oh, man. Well, the mesh. I'm going to talk about this because this is nice. Pantyhose is cheap and a sufficient mesh to let light through, but stop the white color of the LEDs, so it's a lot easier to see the text scrolling. You can see the text scrolling pretty easily in person, but over film with a camera, pantyhose is just thin enough that it lets light through and thick enough that it blocks the white face of the LED. It's also good and tight and will hold the electronics in place. If you don't want to put holes in the hat, assuming you have a top hat form factor, you can run the wires around and the pantyhose will just adhere it to the hat since it's a mesh that pulls tight. It's cheap. It's nice. It works. I like those qualities in anything. But I can't find where I left the other leg of it. And since I can't, we're going to continue. Okay, so for the LEDs, I'm going to need to put them close together. That side, the middle. So I'm going to go with kind of a block on the vertical column and a little block across there. Because these bonded together, should I just do a single piece? Is there any reason not to?
I say do it in a single piece.
Yeah, I think that is prudent. Okay, the next question I need to solve is, do I want the soft part on the hat or the Velcro-y part on the hat? I think it makes more sense to put the Velcro parts on the hat, because then you can always remove the LEDs and slap something else on there. If you want to swap out for patches, if you upgrade your LEDs, that is always an option. I am going to go ahead and cut this in half, though, so the LEDs themselves are not tied together, but what they are connecting to is tied together. And then I'm going to take another one and just cut it in half. And that's going to hold the outsides of these down.
And this is also the fun part of like working with microcontrollers, is that you still get to have fun coding and like troubleshooting coding, but it's one of the few scenarios where you still get to do something hands-on. You do get to mess with wires and figure out how to build something, get Velcro, get tape, and just sort of build something physical, which I found to be very satisfying. Because with code, you don't always get to see it impact the physical world. But with the power of microcontrollers and sensors, you do. And I found, especially for beginners, that can be really powerful, seeing something that you code affect the outside world. Like, for instance, LED lights.
And the LEDs are just so cool. Okay, put a mark on there. That way I know how tall the LEDs are, so I can make sure that the Velcro strip goes below that.
And see, this is the difference between some sort of the people who do microcontrollers, is that I would just be guessing it and be off by like 2 inches. But then other people like you are a bit more prepared, and they will do things like measure before they just go for it.
I will tell you, building a hat ahead of time is really helpful when it comes to, oh, I should just measure that. The tape, making sure that I got the orientation of the two matrices, was because this was backwards. It would start in the middle and then scroll to the opposite side. And I learned from that, I should double check stuff before I slap it on a hat. I had to, for as much as I struggled getting the cables into the hat, I struggled a lot more getting the cables out of the hat and then swapped around. Because with getting the cables in the hat, I had the luxury of being able to say, I had the luxury of finishing my sentences. I had the luxury of not having the cable already in there, so I could grab the X-Acto knife and then just slap it into place. Forgot to make a mark so I know where this one is. I have adhered it. Okay. That goes there. That goes there. That's good enough. When trying to pull the cables out of the hat, I had to be very careful and not accidentally rip the cable. And I also was not able to finish the sentence, it would seem. Not able to grab an X-Acto knife easily and just increase the size of the slot I had made. Okay, so let me see. So one side of the hat has a mesh going there, and then the corresponding Velcro hooks going there and there. And then I'm just going to repeat the same on this side. We already have the top, so I just have to get a little bit of Velcro along the side, and it should conform to the curve of the hat decently well. And with that, I'm also going to want to, might as well completely fasten this one down. That way I can get the distance correct. And I can adjust their height later.
And so far, throughout this whole process, all we've done is just sort of learn about some of the basic Bluefruit and sort of Arduino components we're using, wire them together to test that they work, follow the sort of Adafruit like getting started guide and putting up some basic code. And with that and a little bit of editing some of that code, we're able to have a pretty functional hat already. So it's pretty amazing that this isn't too out of the realm for people to do. So if you feel like, oh man, like working with microcontrollers and like building a hat with LEDs, like that's so intimidating. There are really a lot of great resources and tools to make it accessible for people, which is partly why this stream exists, to show people that this isn't so far out of reach.
And adding to that, because we've selected the Bluefruit, we don't need to buy extra sensors in order to play with the microphone or the accelerometer. We already have access to a microphone and an accelerometer, so we can make the hat responsive to behaviors. So there we go. We have fastened LEDs on the hat. Now the inside of the hat is a bit of a mess, but that's okay. We can tape a lot of this down, and then we can also tape the microcontroller into the hat. And then we'll just have a little cable slotting out. And I'll show you a couple of things that we can do around that point. And at no point in this did we solder, which I think is another thing that is particularly nice. I don't mind soldering. I'm not great at it, but I don't mind it. But if you've never played with electronics before, that can be something that is just not for you at that point in time, and that's okay. So we're going to do some more Velcro to fasten the microcontroller into the inside of the hat. We're going to have just a cable sliding out of it, like a old time you wearing a wire type character. So we'll just have a wire that'll run down the head. Alternatively, you've got a top hat, at least in this formation. You've got a lot of space for battery packs. You've got a lot of space for anything else you're interested in. You don't need to have this hat tethered to your PC. We are going to put the microcontroller inside. And for this, I'm just going to unplug it. And then we'll tether this in here. Let's get that angle. Cameras are hard. It'll be sat in there. And then we can have the cable running out this direction so that it's decently comfortable. But if you want to get a battery pack, you can always grab a little very small micro USB extender, and then it can still be in the hat, and none of this is in frame. Okay, fake head, thank you. Your duty has been exceptional. You can get a little micro USB extender, slot this in, it's still in there and out of the way, and then place the battery into the base of the hat, and wear it as a hat. And just because you have the microcontroller sort of quasi-permanently set up there doesn't mean that you don't have the ability to put a battery pack in the hat and walk around with this hat on. One of the things we were mindful about before is trying to make sure that the brightness on the LEDs wasn't way too high. And that lets this microcontroller and a USB port drive the LEDs, which is pretty great. Not having to worry too much about power is a really, really nice thing, because power can get super annoying. And adjusting your LED brightness is a really easy way to take care of that. So I'm just slapping the sticky side of the Velcro on the base of the microcontroller. It will probably be a pain to deal with, the alligator hooks, if and when they come off. But you're not soldering, we can tape stuff into place. And we have a hat. We don't need this taped down at the moment. I'm going to get that plugged in. And we have been testing it at multiple stages of the build to make sure that things work. And
ta-da, we have a hat
yeah.
with scrolling text, so you can be just as cool as Pablo during a release stream.
So without the pantyhose to hold this down, it's a little wonky, a little harder to see. And it looks like I will need to let's see, this is my right hand, this is my left hand. Looks like I'll need to, cameras are hard. It looks like I'll need to kind of help fasten that down in a bit more of a rigid form. But I now have a second, no, that's not going to be in frame, second fancy hat with text scrolling. Now, easy ways to extend this. If you clap, it can be brighter. If you tilt your head to one side or the other, it's got an accelerometer on there, and it's very easy to access. You can very, very easily make the text scroll slide one way or the other, more or less than before. And we're going to run really quickly over to...
yeah, and to comment, so this is one of the powers of the little blink fruit, like the little circular microcontroller we're recommending. It already comes with a lot of sensors integrated. So, I mean, like you mentioned, like if you tilt your head, you can have the text tilt too. Or if you clap, it can grow brighter, which would be really cool if you're like giving a talk at a conference that you see the text get brighter as people clap. There's a lot of fun things that you can do because there are already so many sensors integrated on this little circuit board already. So it really makes things accessible too.
It's super, super nice. There's a lot of sensors. You can very, very quickly grab the accelerometer, which I'm going to find if I can find sound, drum, light, temperature, storage, CPU, capacitive touch, audio out. Is it just going to be built-ins?
I mean, so one of my favorite things to do is literally go on the Adafruit website and just look at all of their sensors and just see if anything like pops out at me. Like there are sensors for things I didn't even like think about. Like for instance, I mentioned earlier my little like water sensor where like it can tell me how much moisture is in the ground via like conductance. And I'm like, oh, I didn't realize that was a thing. Oh my gosh. I just opened up a lot of ideas. Adafruit is one of sort of the partners for our community, and we love Adafruit and the things they do to help make coding and microcontrollers more accessible. They also have their own Discord server that we definitely recommend you can go visit if you sort of want to dive deeper into the microcontroller world. We find the Adafruit community are super welcoming, especially for beginners and people just getting started. And I want to briefly shout out Katney, who has helped us so much with sort of prepping for the stream in the comments, and also Tammy Makes Things, who's sort of been in and out of the comments, helping answer questions or providing commentary. Thank you both for sort of helping with the stream.
Yeah, I'm going to echo those really quickly. If you're ever bored, which I don't know how often that happens with you guys, they have a random function for Learn Guides, and you can just click it and then see different Learn Guides that they have, which makes it really, really easy to explore. Let's see.
And Keith, if you do want to look on Discord, Katney has linked the guide that you wanna look at.
Thank you. Let's see. Because it's literally import this. There we go. Thank you. It's import and then print. So there we are. We're going to go ahead and just do that right now because...
And I can promise you, this is not as easy as if you were doing it on C. I have done accelerometer control in C, and it has been a full half an hour trying to figure out how to print the acceleration and get the library installed and compiled and working on the microcontroller. And in Python, the beauty of Python is that it's an import statement and a print, and you're done.
Can't remember because I didn't read the earlier code. We're going to see if that works. It's probably not going to work. Yeah, I didn't read the earlier code in the Learn Guide. Nope. We're going to run over here. Thank you, Katney. This is one of the fun things about finishing your sentences. Here we are. Okay, cool. Sorry, I really wanted to get to this point because I'm really excited at the notion of the accelerometer being so easy to get to. Very easy to take a text scrolling hat and add some functionality with the acceleration. And you don't need to buy a secondary sensor. And that is absolutely astounding. And I love it. And I hope you guys have found this to be a fun and enjoyable workshop. We kind of were hoping to keep it nice and relaxed and get through a nice small build to make a fancy hat.
Yeah, so thank you. We've been going for just over 2 hours now, so thank you so much for people joining us for the stream. Obviously, we're recording this via YouTube, so you can always go back and rewatch things. I want to thank you, a big shout out to Keith for sort of coming up with the idea from this workshop, doing all of the research for it, the prep for it, and showing us how to do this. Thank you so much. This was a lot of work, and it's greatly, greatly appreciated. So thank you, Keith, so much.
Thank you. I also want to thank you, Kat, and I really want to thank Katney as well. The two of you have been exceptionally helpful in prepping this, and also want to call out Robin and Turtle and a good number of other people, Tammy in the stream as well. This workshop was a lot of fun to put together, and Janine has been exceptionally kind in putting up with me going, okay, well, what about this? Could I do this? And she has done a lot of effort in the background to help make this stream possible. And I think a lot of the server is, a lot of the staff on the server are excited about the opportunity to explore more workshops for different kinds of builds, not just with physical stuff, but with different programs and libraries different members of the staff are really excited about. And Janine has been exceptionally helpful in leading that project exploration.
Yes, so thank you. We will be posting a link over on our Discord channel, and we'll also be sure to edit it in the description of this YouTube channel. But it'll be a link just sort of compiling all of the resources, different tutorials that we recommend people follow, or good reading, as well as links to where you can sort of buy some of these components. We mentioned a lot of things, but there are really a lot of good starting places for any sort of skill level. So whether you're just getting started and sort of just want easy things to clip together, or if you're a bit more experienced and want to kind of dive into a bit more soldering and using more of the complex sensors, we'll have things for that whole range. But also, this is my open invitation where if you are seeing this workshop and you're like, oh, this is so cool, I know something that I could also give a workshop on. Come talk to me over in Discord, and we can definitely make it happen. A big part of Python Discord are sort of these education and interactive streams. So if you have something that you kind of want to give a little bit of a workshop or a talk on, come talk to me, and we have the resources to make it happen. So otherwise, I will let Keith sort of wrap up the stream, and we will end it. I will keep the Discord live chat open for sort of the remainder of the day for any questions. So let me know. But otherwise, Keith, you are welcome to sort of finish off the stream.
Okay. Yeah. Thank you, everyone. This has been delightful. It was a pretty low-key stream, and I hope this has helped make you think of different ways you can bring your Python experience into the world around you. CircuitPython isn't the only way to do it, but I found it to be a very nice and easy way, and especially for projects around the house, I like nice and easy. And I hope you found this fun, and that's about it. Thank you, everyone.
All right, thank you so much. I do believe I need to wait 10 full seconds before ending the broadcast. Otherwise, it'll clip off what happens. But if not, everyone gets to hear me say that. So I'm going to give it a couple of more seconds, and I'm going to end the broadcast now.